In this lesson, we are going to learn how to solve equations involving rational exponents. To start, we have a simple equation. We have x to the 3/2 power equals 27. Now, there's two methods I'm going to use to teach this problem. Method number one is to treat it as a radical. So take this, and instead of having x to the 3/2 power, write it as a root. This would be the square root of x cubed equals 27. And the goal here is you're going to get rid of one thing at a time until the only thing left is x. So for starters, you have that square root kind of holding things down here. We know to get rid of a square root, you would just square both sides. So the square gets rid of the square root. That's going to leave us with x cubed equals 729. 27 to the second power, 729. Next, we have to get rid of that cube. Well, if a square and a square root cancel each other out, if you want to get rid of a cube, you're going to have to cube root it. Okay, so the cube and the cube root cancel each other out, and you would be left with just a regular old x equals the cube root of 729. So I'm using my calculator here. Cube root of 729 is 9. Now, that's method number one. Method number two is actually going to leave the equation in its exponential form and solve it all at once. So if I leave this as x to the 3/2 power equals 27, and your goal is to get x by itself, the other strategy you could take is to use an exponent to get rid of your exponent. So like here our exponent is 3 over 2. The opposite of 3 over 2 would be 2 over. So on both sides, I'm going to raise it to the 2/3 power. 3 over 2 times 2 over 3 cancels out. And you would be left with just a regular x. And on the right-hand side, you actually have to go type this in your calculator. 27 to the 2/3 power is 9. Not 27 times 2/3, but it's an exponent. So make sure that if you type this in your calculator, that you type it in as an exponent. 27 to the 2/3 power. Let's try. Method number one, we're going to treat this thing as a radical. So instead of writing it as an exponent, this is going to be the 4th root of 8 minus 2x to the 5th power equals 32. And your goal here is to get rid of one thing at a time until the only thing left is just x. Notice that everything is locked underneath that root. So the first thing I'm going to do to get rid of the 4th root is to raise both sides to the 4th power. The 4th power will cancel out the 4th root. So now we have 8 minus 2x to the 5th power equals a really big number. 32 to the 4th power is, oh goodness, 1,048,576. 1048576. Okay, all right. Continuing on, we want to get rid of that 5th power. So to get rid of a 5th power, you're going to use a 5th root. So I'm going to take the 5th root of both sides. The 5th power cancels out the 5th root. So now we just have 8 minus 2x, and here I'm typing this into my calculator. The 5th root of 1048576. The 5th root of that number is just 16 there. That looks a lot better. And we're just going to continue going through and solving for x. I'm going to subtract 8. This is a positive 8, so we subtract 8 on both sides, which leaves us with negative 2x equals 8. And last, we can divide by -2 on both sides. So our final answer is x equals -4. Now, method number 2 is going to be very similar. The only difference is we're going to leave our exponent there. So the original problem was 8 minus 2x to the 5/4 power equals 32. Rather than changing it to a radical and getting rid of one thing at a time, we're going to get rid of this exponent all at once. So the opposite of 5/4 would be 4/5. So we're going to raise both sides to the 4/5 power. Now, 5/4 times 4/5 will cancel out. Just remember that it's the exponent. So we're going to have 8 minus 2x equals 32 to the 4/5 power. That's an exponent there. 32 to the 4/5 power is just 16. So now from here, you can easily go through and get x by itself. All we have to do would be subtract 8 on both sides. That gives us -2x equals 8. And last, we divide by -2 on both sides. So our final answer, x equals -4. You can use either one of these steps, either one of these methods in order to solve for x. You get the same answer either way. Let's try this one. Method number 1. We're going to convert this thing into a radical. So we've got that 6, and then I'm going to treat this as the cube root of x to the 5th power minus 11 equals 1,447. Okay, the whole goal is to get rid of one thing at a time until the only thing left is just x. So remember, the idea is to work your way from the outside in. So I'm going to get rid of this constant first. You have this minus 11 hanging back there at the end, so we're just going to add 11 to both sides. So now we're down to 6 cube root of x to the 5th power equals 1447 plus 11, 1,458. Now we're going to get rid of that coefficient that's out there in the very front. We're just going to divide both sides by 6. Gets us down to cube root of x to the 5th power equals 243. Now, I have that cube root on the outside. To get rid of the cube root, we are going to cube both sides, right? If you cube a cube root, the root will disappear. So we get x to the 5th power equals a pretty big number here. 243 to the 3rd power is 14,348,907. That's a huge number. But our last step is to get rid of that 5th power. To get rid of a 5th power, you have to do the 5th root. So the 5th power and the 5th root cancel out. We got this big old thing left to type into the calculator. So the 5th root of that giant number is just 27. So my answer is 27. Now compare that to method number 2. Method 2, we're going to leave this thing as an exponent. We're going to go through very similar steps in order to get x by itself. I'm still going to get rid of the constant at the end, so I'm going to add 11 first. Next, I'm still going to divide by 6. The difference is when I get down to just x to the 5/3 power, I'm going to use the inverse exponent to cancel it out. The opposite of 5/3 would be 3/5. So I raise both sides to the 3/5 power. 5/3 times 3/5 cancels out. which leaves us with just x. And if you go type this into the calculator, 243 to the 3/5 power is just 27. So that avoids getting some really, really massive numbers by doing those steps using an